We are now at section 7-3, confidence intervals for the mean when sigma is unknown. Now, the standard deviation for the population is unknown, but the standard deviation for the sample is known. When sigma is known and the sample size is 30 or more, or the population is normally distributed, if the sample size is less than 30, the confidence interval for the mean can be found using the Z distribution. That's what we just did in 7.2, as shown as what we were learning in 7-1. However, most of the time, the value of sigma is not known, so it must be estimated using the standard deviation of the sample, which is namely the standard deviation of the sample. When S is used, especially when the sample size is small, critical values greater than the values for z sub alpha over 2 are used in confidence intervals in order to keep the interval at a greater confidence level, such as 90%. These values are taken from the student's t distribution, but most often called the t distribution. So go ahead and grab your formula cards. Go ahead and flip over to table F. You see the t distribution. Have your formula card handy. Have sticky notes for vocabulary, for highlighting. You might want to have some highlighters. You might want to have index cards, but here we go, 7-3, confidence intervals for the mean when sigma is unknown. To use this method, the samples must be simple random samples, and the population from which the samples were taken must be normally or approximately normally distributed, or the sample size must be 30 or more. Some important characteristics of the t distribution are described now. And remember, everything that we're doing in our book is basically rigged. This is information that is vital for you when you do additional statistics courses, and especially if you take if you decide to go and pursue a master's or a doctorate, you're going to have to follow these guidelines. For right now, they're mentioned, we're made aware of them, and we'll keep looking and going. Like characteristics of the t distribution. Here are some things that make it like the standard normal distribution. It's bell-shaped. It's symmetric. Its mean, median, and mode line up at 0. The curve approaches but never touches the x-axis. But it differs from the standard normal distribution in the following ways. The variance is greater than 1. The t distribution is actually a family of curves based on this new thing called degrees of freedom. Highlight that, underline that. We're going to play around with that. And that is related to sample size. Good thing to underline. As the sample size increases, the t distribution approaches the good old standard normal distribution. Many statistical distributions use the concept of degrees of freedom, and the formulas for finding the degrees of freedom vary. The degrees of freedom are the number of values that are free to vary. A sample statistic free to vary after a sample statistic has been computed, and they tell the researcher what specific curve to use when a distribution consists of a family of curves like the t distribution. The symbol df will be used for degrees of freedom. I would start underlining. Degrees of freedom for a confidence interval for the mean are found by, I'd be underlining, subtracting 1 from the sample size. That's it. All you got to do is say my degrees of freedom are, what's my sample size? Take away 1. I'll go ahead and point out on your table there's a df, and these numbers are going to be, they have been generated from the sample size minus 1. And here's a quick picture of the z-curve. And then as we have like a degree of freedom of 5, but then it increases to degrees of freedom of 20, which the sample size would have been 21, it approaches closer to what the z-curve looks like. It approaches more like a normal distribution. I wrote look familiar here because the formula for finding this is going to have critical values at, you may not be able to see that very well, t sub alpha over 2. Does that look familiar? Yes. But this is a whole lot easier to calculate, compute, find, whatever. The values are found in this table F. At the very top, you'll have a row called confidence intervals. If you look at the very top of your table F, Do you notice the very top row says confidence intervals? That's us. It is used to get these values. There are two other rows. One is one tail, one is two tail. So you see one tail and two tail. That is not us. That is later. It's going to show you how to find this. And so example 7.5, can we find t sub alpha over 2? We want a 95% confidence interval. Sample size is 22. To get our degrees of freedom, we take 22, subtract 1. We are looking for degrees of freedom of 21. We want a 95% confidence interval. I've already marked this one. You can get you a sticky note. You can use sticky notes during the test as long as they don't have anything written on them. You're just using them to help your eyeballs. And as I look here, my degrees of freedom would be 21, and I have all of these values from which to select. But the one I want is the 95% confidence interval. That's the third one. So my number that I'm looking for t sub alpha over 2 will be 2.080. And notice right here they've given us a picture, just what you and I were looking at, and it says, yay, it's going to be 2.080. And then it gives us a little bit more information about when it falls greater than 30, it could end up falling between two table values. And if you look further down here, what it's saying is, notice how it gets spacey. They're jumping around. And so it says, uh-oh, what if you end up with a degree of freedom of 73 or of 61? What you going to do? And so it says, text use a conserve, in this text we use a conservative approach. And so if an example, the 68 is closer to 70 than 68, however, if we're going to look at 68, we go conservative and we go down. So if you're looking for what do I do for 68, 68 is between these two. Nobody cares that it's closer to 70. You go down to be a more conservative approach and not get larger, or to get a more liberal approach. It says we round down. And it says at the bottom of the table, when it starts looking like it gets approaching infinity, then it kicks us back over to, oh, well, we're back to z sub alpha over 2. And if you look at the bottom of your chart, you see infinity, and these numbers start looking like, as it says over here, the numbers we've seen before and that you've written on your formula card. So this formula, yeah, it looks just the same, except I did make a note that says this is wrong in the ebook. So if you're specifically looking at the ebook, this formula in the ebook is incorrect. Make sure it reads as this, and specifically that you're looking over here on your formula card, and that the t confidence interval is as you see here, and then you've got z, and now we're about to have t. And if you look at t, you're like, well, duh, yeah, I know this. This is my sample mean. Well, yeah, I know that. Here, I don't have sigma, I have s. Well, no big deal, just plug it in. I still have square root of my sample size. No big deal. Now, instead of using z sub alpha over 2, I'm going to use t sub alpha over 2. I'll minus it on one side, I'll add it, plus it on the other side. Same old, and it gives me a note. Hey, remember, degrees of freedom, take your sample size and subtract 1. It says the assumptions for finding this when sigma is unknown are given next. And this is the last piece I want to say on our introduction. I'm now at page 377. Here are some assumptions. Again, our book, I'll just say, is rigged. But this is great information if you go on. That the sample size has got to be random. You either got to have greater than 30, or if it's less than 30, it's normally distributed. In this text, the assumptions are going to be stated. They're going to give them to us. However, when encountering statistics in other situations, you must check. When I wrote my dissertation, I had to check. And I had to write in my dissertation that I had checked and typed in what I had found and what I used. That these assumptions have been met before proceeding. You're now going to go watch 2 videos that are inside of Connect Math. So go back and look at your directions. It'll tell you which 2 to watch. And then it's going to tell you to come back and do this example. And try to do this example without looking at your notes.